Okay, I hope you guys enjoyed the other little video that you watched. This podcast probably won't be quite as interesting. Hopefully we get a chance tomorrow to talk about the short little 7-minute 2020 clip that you saw in class. This podcast is just kind of a quick review of the formulas that we talked about yesterday and all the work that we did yesterday. So if you didn't get notes down yesterday, you weren't here yesterday, take these notes. Yesterday we specifically talked about the area, and more specifically, we talked about the area of 4 different figures. Recall that when we talked about area, we said that area is really representing the number of square units inside a figure. And the 4 figures that we looked at yesterday, one was a rectangle. And we found yesterday that by just counting the number of square units inside the rectangle, we could find its area. But there was a shorter way to doing it. And that shorter way was using a formula. And the formula said that the area of a rectangle was equal to its length times its width. Or some students said that the area of the rectangle was equal to its base times its height. Both would be perfectly fine formulas to use in this class. A second figure that we looked at yesterday was a parallelogram. And we found the area of a parallelogram by taking the parallelogram shapes, cutting them up, and forming a rectangle. So by doing that, we found that the area of a parallelogram is really just the same as the area of a rectangle. It's its base times its height. Also recall that a parallelogram is really just a 4-sided figure with 2 pairs of parallel sides, and those parallel sides are on opposite sides of the figure. So really a rectangle is a parallelogram, so it only makes sense that the area of a parallelogram and the area of the rectangle are the same thing. The third thing we looked at was a little bit tougher. We looked at the area of a circle. And yesterday you were given a circle and asked to cut it into 12 different slices, or 12 different wedges, and with those wedges you were able to put them together and create a parallelogram. And through some substitution and some work, we found that the area of a circle is really found by taking pi times the radius times the radius. Or we said that really the area of a circle, and I'm going to try and use my pen here, let's see if this works, is equal to pi r for radius, squared. Now, make sure you guys don't make the mistake. Some other classes have already done this yesterday. Some classes said, well, r squared, that's just diameter. R squared is not the diameter. R squared is r times r. The diameter is 2 times r, and 2 times r is r plus r, so that's completely different from r squared. So the area of a circle can be found by taking pi, or 3.14, times its radius squared. The last figure that we talked about yesterday during class was the triangle. And the triangle area was rather easy to find because I told you specifically to take a rectangle and cut that rectangle in half. And how I told you to cut it in half was to cut it from one diagonal to the other. So if you know that the area of a rectangle is base times height, or length times width, when you cut it in half, it's going to have half its area. And when you cut a rectangle in half from diagonal to diagonal, you get a triangle. So we said that the area of a triangle is 1/2 its base times its height, or 1/2 its length times its width. Some students even went as far as saying base times height divided by 2, and that's perfectly fine. So those were the notes from yesterday. If you don't have those down, get them down. You're going to need those for the worksheet that I left for you today. Try to get as much of that worksheet done as you possibly can before tomorrow.